explorers are sending back alarming information to Earth. The Explorer 1, NASA's farthest voyaged shuttle, is still traveling across uncovered regions of the universe almost 50 years after its launch. Scientists are baffled by the frightening data that this well-known space probe is sending back to Earth due to what appears to be a glitch. Join us as we discuss the odd information that the Explorer has been sending back to Earth during its troubled space exploration mission. Scientists have been intrigued by the domain beyond since the Big Bang, and that curiosity is what propelled the launch of Explorer 1 and Explorer 2, among other space missions. Explorer 2 was actually the first rocket to launch, departing from NASA's Kennedy Space Center on August 21, 1977. On September 5 of that same year, Explorer 1 was launched about 2 weeks later. However, how could they switch places like twins? The weight of the two probes is roughly 720 kilos, about the same as a small car. Both were launched during a window of special outer planet alignments that created a slingshot effect, propelling the rockets from one planet to another. However, they had to move at different speeds and in different directions. On December 15, 1977, Explorer 1 managed to pass its identical twin, and since then, it has been our go-to resource for learning about various space-related questions. This was the first rocket to do so when it began its Jovian imaging mission in 1978. At that time, it was nearly 265 million kilometers from our planet and sent a large amount of photos back to us. Explorer 1 completed a remarkable 108-hour stretch starting in January 1979, during which it captured 3,750 images of Jupiter's rotation to produce a time-lapse film showing 10 of the planet's rotations. It passed through the Jovian moon system in February 1979, and a month later, it discovered the small ring surrounding Jupiter. Explorer 1 also made an extraordinary discovery when it found two new moons named Thebe and Métis. Steps were taken to ensure that the spacecraft was prepared for its flyby of Saturn and to prevent a potential collision with Titan, one of Saturn's moons. Explorer 1 also discovered 4 other moons during its orbit of Saturn, including Mimas, Enceladus, Tethys, and Dione. Scientists chose to end the Explorer planetary mission after the Saturn mission was completed and send both Explorer 1 and Explorer 2 beyond our solar system at a speed of 325 million miles per year. In January 1990, the new mission, officially known as the Explorer Interstellar Mission, began. Some of the most renowned photos in history, depicting the Sun and most of the planets, were taken by Explorer 1 on February 14, 1990, when it was 6 billion kilometers from the Sun. These are commonly referred to as the Solar System Family Portrait. There were 60 total shots taken by Explorer 1, bringing the total number of photos taken by the spacecraft to 670. Despite the fact that Mercury and Mars are not visible in the photos due to various factors, the spacecraft's cameras were turned off to conserve power and memory before its journey to interstellar space. In addition to the interstellar probes Explorer 1 and Explorer 2, NASA also operates the Pioneer 10, Pioneer 11, and New Horizons spacecraft. Prior to Voyager 1 passing Pioneer 10 on February 17, 1998, Pioneer 10 was the farthest spacecraft. Explorer 1 continued its journey for another 14 years before it finally entered the interstellar environment on August 25, 2012, with no other space probes in sight to find. However, NASA did not publicly announce the milestone until 2013. Let's fast forward to November of 2018. Both space probes had officially left the solar system when Explorer 2 crossed the heliopause and entered the interstellar medium. Explorer 1 is thought to be 14.5 billion miles, or 23.3 billion kilometers, from Earth. It has continued to provide us with significant data that no other space probe missions have been able to uncover since it entered the unseen region beyond our solar system. The spacecraft has spent the majority of its 45-year journey in space in good health. However, scientists have recently discovered some odd anomalies in its performance. Explorer 1 is currently transmitting puzzling signals back to Earth, giving the impression that it is uncertain of its location coordinates. There is, however, a frightening twist to the issue. Typically, scientists have pre-programmed Explorer to enter safe mode or sound an alarm if it gets derailed in space. But so far, it has not. Also, its antenna, which sends data back to Earth, seems to be in great working order. However, the data it has recently been transmitting is questionable. The Interstellar Explorer is functioning normally, taking instructions from Earth and carrying them out, as well as collecting and sending scientific data. However, readouts from the probe's articulation and control system do not accurately reflect what is happening inside, according to a NASA official statement. What exactly is going on aboard, then? Each spacecraft that is traveling toward interstellar space, including Explorer 1 and 2, has a unique 12-inch diameter gold-plated disc that is loaded with audio and video messages as a backup in case an extraterrestrial species finds the craft. These discs contain 35 Earth sounds, 115 images, 90 minutes of Western music, and greetings from former U.S. President Jimmy Carter and former UN Secretary-General Kurt Waldheim, among other items. They are also stored in 55 different languages. If it was taken over by aliens, they would presumably be attempting to decode the signals. Thoughts that the spacecraft is currently under the control of aliens have been quickly debunked by scientists. Explorer's ability to operate heavily relies on the attitude and articulation control system. First, it always keeps its antenna pointed toward Earth so that scientists can accurately receive data. Secondly, it controls how the spacecraft is oriented. Engineers monitoring the situation currently believe that the attitude control system is working as it should, which only adds to the mystery we now face. Moreover, none of the safety features designed to protect the spacecraft from danger have been activated, according to Susan Dodd, project manager for Explorer 1. This mystery is welcome at this point in the Explorer mission, Dodd adds. The spacecraft is now around 45 years old, which is much older than what was envisioned in the mission plan. Dodd also acknowledges that the rocket's engineering team will face significant challenges in resolving the issue with Explorer 1 due to the distance between us and the space probe. The challenges are considerable, primarily because the spacecraft is about 14.5 billion miles, or 23.3 billion kilometers, away from Earth. This enormous distance presents several complexities that the team must navigate carefully. A rescue mission is nearly impossible given the current technological and logistical constraints. Explorer 1 is far beyond the reach of any spacecraft or repair mission we could conceivably send. The spacecraft's incredible journey has taken it into the outermost regions of our solar system and beyond into interstellar space, where it continues to travel farther away from us every day. Messages sent from Earth at the speed of light take almost 21 hours to reach Explorer 1's current location. This means that any command or instruction sent by the engineering team takes a significant amount of time to be received by the spacecraft. This delay presents a major challenge for real-time problem-solving and troubleshooting. Moreover, once Explorer 1 processes the command, any response or data it sends back to Earth will take an additional 21 hours to return. This implies that two-way communication between Earth and the spacecraft takes an average of 2 days. Such a delay makes it extremely difficult to implement quick fixes or iterative troubleshooting processes, which are often necessary when dealing with complex technical issues. The engineering team must meticulously plan and execute each command, anticipating various scenarios and potential outcomes. Unlike missions closer to Earth, where engineers can quickly send and receive commands, the long communication delay requires a more strategic and patient approach. Each instruction must be carefully crafted to address the known issues without causing additional problems, considering the extended time it will take to confirm whether the command had the desired effect. The significant communication delay also means that the engineering team has limited opportunities to interact with the spacecraft. Each command sent must be effective and precise, leaving little room for error. This requires extensive testing and validation of commands on Earth before they are transmitted to Explorer 1. In addition to these logistical challenges, the spacecraft itself is over 45 years old. Having been launched in 1977, the technology on board, though cutting-edge at the time, is now considered ancient by modern standards. The engineering team must work with equipment and systems that were designed and built in the 1970s, adding another layer of complexity to the problem-solving process. The harsh environment of space also takes a toll on the spacecraft systems. Explorer 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroids for over 45 years. These factors contribute to the wear and degradation of its components, making it even more challenging to maintain and repair. Despite these obstacles, The engineering team remains dedicated to resolving the recent issues. They are exploring various theories about what might be causing the anomalies and testing potential solutions through simulations on Earth. This careful, methodical approach is essential given the stakes involved. Any incorrect command could potentially worsen the situation or lead to a loss of communication with the spacecraft. The team is also leveraging the redundancy built into Explorer-1 systems. Like many space missions, Explorer-1 was designed with backup systems to increase its resilience to failures. The engineering team may be able to switch to these backup systems and restore normal operations if they determine that a specific component is malfunctioning.